By the end of this video, you will have gone from not even having the Arduino IDE downloaded to writing this program, and this program. I do recommend you watch the entire video all the way through, but if you already know a section, feel free to skip past it. In order to write your code and upload it to your Arduino, you need something called an IDE, which stands for Integrated Development Environment, which is an app with a whole set of tools that make it possible to understand code and upload code to your Arduino board. We can open up our browser, search for Arduino software, select the software option from arduino.cc, and then select the correct version for our OS, click Just Download, and follow the steps in the installer. Now that we have it installed, let's take a look at what it can do. The main central area is where we're going to write our code. You can see it already has a few lines of code, which we'll talk about in a second, and it has this nice color coding system, which will help us understand what the different words and symbols mean. We can also use these buttons here on the left to open up a tab which can do 5 different things. We can see our sketchbook, which is where all of our programs are stored. We can download additional software that will help us use non-Arduino boards. We can download software that will help us use different modules compatible with our Arduino board. We can access tools that help us find problems in our code, and we can search through all of our code files. Don't worry, we'll go into more depth about each of these later. Now, this top bar here is very important. We have a check mark which will run through our code and make sure there are no errors, and if there are any, it'll tell us where they are so we can fix them. We have this arrow here which will first run through our code and make sure there are no errors, just like the check mark, but it will also then upload our code to the Arduino board. This button here allows us to do some more in-depth error assessment on some Arduino boards, but I haven't really used it. This drop down here is very important. If we click Select Other Board and Port, we can search up our board, for example Arduino Uno. We can plug our board into a USB port, and a new option will appear on the right for us to click. We can see our board has been selected, and we can now upload code to it. We also have 2 tools here in the top right corner that help us talk to our Arduino and receive information from it. All of these features make it easier for us to program our Arduino, so let's start doing that. So there's already a little bit of code here, and this is the core of almost every program we'll make. We have 2 sections here, which are called functions, each of which has a sort of intro and then some curly brackets with space in between. Now the top section is called the setup, and any code we put inside the curly brackets of this function will be run when the Arduino starts up. So if we put some code here that told the Arduino to turn an LED on and then turn it off, it would do that once. The bottom section, or function, is called the loop function, and any code we put in the curly brackets of this function will be run over and over again after the setup function and as long as the Arduino is on. So if we put some code in here that told the Arduino to turn the LED on and off, it would do that over and over forever, blinking the LED on and off. There's also a couple of gray lines that start with 2 slashes and look like they're meant for us to read. Those are called comments, and if you put 2 forward slashes, then you can write whatever you want on the line and the computer will just ignore it. It'll actually trim it out before uploading to the Arduino, so it doesn't even take up space. You can use these if you're working with others or just to remember how certain parts of your code work. So these 2 functions are special functions that the Arduino will automatically run. But there are lots of other functions too that we can run manually, or we can even create our own. One function that's built in is the digital write function, which we can call by typing out digital write and then a semicolon. So digital write is a function that does a specific task, and the semicolon tells the computer that that's the end of that specific task, just like a period tells us that it's the end of a specific sentence. Some functions, like the setup function, don't need any input to run, while others do need input. For example, let's say we were going to show the day of the week on an LCD screen. It wouldn't be very helpful to have a function that could only show Sunday on the LCD screen, but it would be helpful to have a function where we could tell it Sunday or Monday or Friday, and it would show whatever we put in on the LCD screen. So each function can have 1 or more parameters that we send to it and it uses, like printing that day of the week. Back to our actual program, the digital write function does 1 task. It takes one of the ports on the Arduino and it turns it either on or off. So it needs us to tell it which port it's writing to and whether that port should be turned on or off. Inside of the parentheses, we'll type the port it's going to access, let's do 13, and either high for on or low for off. Now I have my Arduino Uno connected, we can see that from this drop down here, so I can hit the upload button to check if I've made any errors, and if not, it'll upload the code. Now remember, code is a way for us to talk to a computer, and computers don't have any intelligence or understanding. So all they can do is use what you write in exactly the way they were programmed. So if we make any mistakes, it won't understand us, and typically it'll tell us, hey, I don't understand this bit, can you fix it for me? A little weirdly because it's not a human and it only has certain ways it can communicate with us. We'll learn how to understand that later, but for now we haven't made any mistakes, so let's see what our Arduino is doing. If we connect an LED with the long leg in port 13 and the short leg in the ground port right next to it, we can see it lights up because we told the Arduino to turn port 13 on. If we switch the long leg to port 12, it won't light up because we haven't turned that port on. So let's go back to our program and we'll switch the port we're turning on to 12 and leave it set to high. This time though, I don't want to leave it on forever, so I'm going to run digital write 12, low on the next line, and this will turn our LED off. However, if we were to upload this, our LED wouldn't seem to light up at all, and that's because immediately after we turn port 12 on, we're turning it off, before there's even enough time for the LED to really light up. So in between these two lines, I'm going to run the function delay, and delay just waits for a set amount of time, which we can input, and then lets the Arduino go on to the next line. Now, the parameter for delay is a number of milliseconds, or thousandths of a second. So we'll need to send 1000 in order for the program to wait for 1 second. Now, if we upload that and we haven't made any mistakes, we can see that the LED is set to high. The program waits for 1 second and then the LED is set to low. All of this happens in the setup function, so it only happens once when the Arduino is turned on. Let's move it to the loop function. I'll just cut and paste these down below, but once again we're going to have the same issue where we're turning the LED on, then waiting for 1 second, then turning it off, but then we're immediately going back to the start of the loop function and turning it on again. So there's not enough time for it to really turn off. So we need to add another delay function. Again, let's do 1000 milliseconds, so it turns on, waits, turns off, waits, and then starts the cycle over. Now, if we upload this, we can see the LED is going to keep blinking on and off forever. Congratulations, you just wrote your first program and it works perfectly. Hit the subscribe button so you don't miss future tutorials. So functions are pieces of code that do something. But what if we want a piece of code to hold a piece of information, something that we'll use in one of our functions? Well, that's called a variable. A variable is a digital box that stores a piece of information, like a number or a word or something else. And it's called a variable because it can change what it holds, but only within certain limits, just like boxes can only hold certain sizes of items. For example, let's create an int number. Again, I used a semicolon to tell the Arduino that the instruction is over and it can move on to the next instruction. The variable that we created is called number, that's its name. This means that we can access it by saying, hey number, what do you hold? And we can change it by saying number, switch to holding this value. It is of type int, which is short for integer, which, as I'm sure you know, means a positive or negative whole number, like 1 or -42 or 1309. So while we can change number an infinite number of times, we can only change it to values that are integers, so we can't change it to hold a word or even a decimal value like 1.2. In order to actually change number, we can go into our setup function or our loop function and say number equals 1. Now number is set to 1 all the way up until we change it again, say if we wrote number equals 2 at the bottom of the loop function. Now it will be 1 all the way through this code, and then it will be 2 down here, and then the loop starts over and it's 1 again, then it's 2 again at the bottom. We can also set it at the top when we first create it. Int number equals 4. As we create it, we set it to 4, and it's 4 all the way through the setup function until the first loop runs, then it's 1 and then 2 and back in the cycle. It's never 4 again after that point. So in addition to the integer type, we also have the float type. And a float is a decimal number, so this could be 4.7 or 6.3 or even 1.0, which we can abbreviate to 1. Keep in mind, we can say float decimal equals 1, but we can't say int number equals 1.7 because the float can automatically say, oh, well 1 is the same as 1.0, let's use 1.0. But the integer will try to say, let's just ignore the decimal part, and 1.7 is the same as 1, which obviously isn't true and will cause problems. Now, there's two more variable types you're probably going to use a lot. The first is booleans. A boolean is abbreviated bool, and we'll call it test bool, and it can only be set to true or false. Much more interesting are strings. A string is short for a string of characters, meaning a word or a sentence. We can create a string with a capital S by saying string words and set it equal to, in double quotes, hello, or anything else that's a string of characters. Just like with the other variables, we can change these lower down by setting words equals I just changed this string yay, or whatever else we want to change it to. What are all of these variables used for? Well, strings are actually one of the most useful types, as we can have the Arduino send them to our computer. In order to do this, we have to tell the Arduino that we want to set up communication with our computer in the setup function by typing serial.begin 9600. Now, there's a lot to unpack in this short line. First, you'll notice we're once again using a function, begin, and we're passing in 9600 as a parameter. However, this function isn't just built into the Arduino. There's actually a digital object called serial. This serial object is a piece of code responsible for all the communication with the computer. So when we want to start up communication with the computer, we say, hey, serial, start this up for me. And in order to communicate with the computer, we need the Arduino and it to agree on how fast they'll be sending info back and forth, which is called the baud rate. In this case, I've told the Arduino to send and read at 9600 baud. Now, for the computer to understand, we can open up the serial monitor using this magnifying glass here and set the baud rate to 9600 baud. Now, the computer and Arduino are both expecting to send and receive info at the same speed, so they can understand each other. But we haven't actually sent any information yet. So in order to do that, sometime after we set up serial communications, we can run serial.print to send our message. In this case, whatever is in the variable words. If we upload our code, the computer will be able to read this communication and print it in the serial monitor. Now remember, we haven't changed our words variable yet at this point in the program, so it's still set to hello world and not I just changed this string yay. Now, if we run this program multiple times, we can see that the words are all on the same line, which doesn't look very nice. So instead of using serial.print, we can use serial.println, short for print line, which will print the parameter and add a new line after it prints. So if we type serial.println testing, we can see that it prints hello world and then adds a new line and then prints testing. And we can't see it, but there's a new line after testing as well. Conveniently, the serial object can also automatically convert numbers into strings through the print or printline functions. So if we simply type serial.println5, it'll actually auto-convert that to a string and print out a 5. There are actually a lot of ways to change our variables other than simply setting them equal to a new number. For example, we could say decimal equals number plus decimal. And here, number is converted to a decimal, added to the value of decimal, and then that's all packed back into decimal. 1309 plus 1.0 equals 1310.0. But we can actually shorten this using the plus equals shorthand. If we say decimal plus equals number, then we're saying the same thing, decimal equals decimal plus number, but shorter. And this works on the other operators as well. We can say decimal times equals number, or decimal slash equals number to divide, or decimal minus equals number to subtract. Let's clear out this code because I told you before that we can actually make custom functions, and that's what we're going to do now. In order to create our own functions, we're going to imitate the format of the built-in functions. So the first thing we need is a return value. The return value is when the function runs and then at the end says, here you go, you can have this value for using later on. In this case, we're returning void, which means we're not returning anything. So when the Arduino calls the setup function, it doesn't expect anything to be returned. But we can create functions where we do expect it to return something in just a moment. First, let's create this void and name it print something, and then we'll have parentheses and then curly brackets. Inside of the curly brackets is the code of our function, serial.println something. Now, in order to run this function, in the setup function, we'll still need to set up serial communication using serial.begin 9600. Then we can type print something and it will run just like we did with digital write, except that our function doesn't have any parameters. If we upload this, we can see it printed out something. Now, to make our function a little better, let's add a parameter. In the function's parentheses, we can add a parameter, which is just a variable, so we have to give it a type, in this case string, and a name, in this case message. We don't need to set it here because we'll be getting a value sent from the setup function, which is where we're running it. Then we can change the something that we're printing out to message. And now when we run the function, we'll need to pass in a string. I'll do Saber C++. Now if we upload the code, we can see that it sets up the serial monitor and sends Saber C++ to it. Then it puts Saber C++ in the print line statement and prints it out. So that function was designed to do something and not return anything. Let's add a new custom function and we'll make it of type int. And in the parentheses, let's put int number 1, comma, int number 2. We separate each variable with commas, just like when we're running the function. Then we can say return number 1 plus number 2. And now we'll run the function, pass in two numbers, and get one number, the sum, returned to us. In the setup function, we can type add ints and put in 1 and 2. But this doesn't give us the solution. We need to remember that add ints is a function and also an int because it returns an int. So we can say int solution equals add ints. So we're creating a new int variable called solution, and we're setting it equal to the sum of the first and second numbers that we're passing in. And then we can run serial.println solution. And if we upload the code, we'll see the solution, in this case 3, is printed out. We can change the numbers to whatever we want, and it'll give us the sum of those two numbers. Before we make our second awesome program, we need to learn about one more thing: if statements. An if statement is like a gate that says, if this is true, you can do my code, otherwise you can't. When we type if and then parentheses and then curly brackets, we get our if statement. Inside of the parentheses is the condition, which is a Boolean value. So we could just put in true, which would mean that the code inside the curly brackets always runs. Or we could put in false, so the code in the brackets never runs. But we can also create a Boolean statement using something other than a Boolean. For example, 0 is equal to 0. Two equal signs means is equal to, and it means we're checking if the left number or variable is equal to the right number or variable. So 0 is equal to 0, that's true, and the code will run. But 0 is equal to 1, that's false, the code won't run. We could also create an int number to check and set it equal to 1, and then say if number to check is equal to 1, which is true. In addition to checking if a number is equal to another, we can check if a number is greater than or less than another number. So we can say if number to check is less than 1, serial.println true. Now if we upload the code, we can see that nothing is printed because number to check is set to 1 and 1 isn't less than 1. If we set number to check to -5, we'll see that true is printed out because -5 is less than 1. If we switch it to a greater than sign, then we won't see anything because -5 is not greater than 1. But it doesn't end with just one if statement. We can connect the if statement to an else statement, and then the else statement will run if the if doesn't run. I'll run serial.println false inside of the else statement when we check if -5 is greater than 1. So if the stuff in these parentheses is true, we'll get the if statement code. And if the stuff in these parentheses is false, we'll get this else statement code. But there's also an else if statement, which goes in between the if and the else. So now we can check three things. Let's say in the first if statement we check if number to check is equal to -4, and we'll print -4. Then in the else if statement, we'll check if number to check is equal to -5, and we'll print -5. Then in the else statement, we'll print something else. If we run it, we get -5 from the else if statement. If we change number to check to -4, we get -4. And if we change it to -3, we get something else. So if the if statement is true, we get that. If not, we check the else if, and if that's true, we get that. If the if and the else if are both false, we get the else statement. So we still get one of the three. Now we can have as many else ifs as we want, and we don't have to have an else statement, so we can cover as many options or ranges of options as we need. Now that we know all of these math operations and if statements, we've talked about printing stuff from the Arduino into the serial monitor on the computer, but we haven't talked about sending stuff from the computer to the Arduino, which we can also do. If we clear out what we've got so far, we can start on a new program, and what we're trying to do is get two numbers from the user and show them the sum of those two numbers, int number 1 and int number 2. Then in the loop function, we can start by telling the user to enter the first number. So serial.println enter first number, colon, space, parenthesis, semicolon, everything. Then we need to wait for them to enter the number. So we're going to say while serial.available, parentheses, because this is a function, is equal to 0, and then add some curly brackets. So we have this keyword while, which is kind of like if, but it keeps running over and over again as long as the condition is true. So while whatever in the parentheses is true, we're going to do the code inside the curly brackets over and over. And as soon as what's inside of the parentheses isn't true, we're going to stop doing it and move on to whatever's after these braces. So right now we're not putting anything inside of the curly brackets. So we're going to check if serial object, which is responsible for communication, has nothing for us. If it has nothing for us, we're going to sit inside of these empty curly brackets and do nothing until the user enters a number for us. Once it has something for us, serial.available won't be 0, and the while loop will be over, so we can move on to what's next, knowing that we just got input And what's next is to set number1 to serial.parseInt. This means that whatever the Arduino got from the computer, the serial object is going to look through and try to find an int, and it's going to put this int into our number1 variable. Then we're going to do this again for the second number, serial.println, enter second number, and then do another while loop while serial.available is equal to 0, and then after that we'll set number2 equal to serial.parseInt. Once again, we'll look through whatever the user put in and try to find a number. Now that we have both of our numbers, we can serial.print, no new line, the sum is, colon, and then serial.println, number1 plus number2. Let's try it out. It asks us for the first number, and for the second number, let's do 100. And there we go, it printed out the sum is 105. And it also restarted the loop, so now it's asking us for a new number. If this video has been helpful so far, make sure to subscribe so you don't miss even more helpful Arduino tutorials. So right now we can add the numbers, but that's pretty easy for us humans to do anyway. Let's try making it so we can choose whether to add, subtract, multiply, or divide the two numbers. At the top, we'll add a string operator. So we're already asking for two numbers to play around with, but we'll also need to ask for an operator, which we'll do by telling the user after the two numbers, serial.println, enter an operator, plus, minus, times, or divide. And then, while serial.available is equal to 0, we'll do nothing, and we can't use parseInt because we're not getting an int, we're getting one of these symbols. So we'll need to use serial.parseString. Then, instead of printing the sum is, we'll print the solution, because it could be any of the operations. And after that, we'll check if operator is equal to plus, and if it is, we'll run serial.println, number1 plus number2. Else if operator is equal to minus, we'll do serial.println, number1 minus number2. Else if operator is equal to asterisk, we'll do serial.println, number1 times number2. And in the else statement, we'll do serial.println, number1 divided by number2. Now we can enter two numbers, pick an operation, and get our result. If you made it this far and created that absolute beast of a program, you are doing great. We've got just a few more things to learn for our final program. So save and close this one, hit the like button, and let's go. So variables are values that can change, but what if a value doesn't need to change? Well, then we can be more efficient by making it a constant like this. Hash define constant value 1. This lets us use the constant's name, in this case constant value, all caps, so we can understand our code, but the IDE will actually trim this out and simply put a 1 wherever constant value is used, so we're not actually creating a full variable. We're just pretending to create one to make it easier to read. So we've talked about a lot of variable types, but let's say we have 10 LEDs connected to ports on our Arduino, and we want an easier way to keep track of them, instead of just creating 10 variables and naming them LED 1 port, LED 2 port, LED 3 port, LED 4 port, LED 5 port, LED 6 port, LED 7 port, LED 8 port, LED 9 port, LED 10 port. We can create an array, which is a list of values where each value has an index starting at 0 and going up to whatever is necessary, and we can just say, get the 0th value from the array, and we'll get that value. Or set the 7th value of the array to 5, and we'll set that value. To create an array, we'll need the type, in this case int, then the name, in this case I'll say LED ports, and then we'll put square brackets with the number of items in the array in between. Now, the array can only store 10 items, so we have to be careful not to ask it for an 11th value which doesn't exist. Then we can set the items in the array by saying equals, and then inside of curly brackets we can put the items of the array. In this case, I'm going to put LEDs on port 4, 5, 6, and so on up to 13. Don't forget to add a semicolon on the end of this, as it's an instruction. We're telling the Arduino to create an array and set it equal to all of this. Now that we put the LED ports in the array, how do we access them? That's where for loops come in. We talked about while loops earlier, and these are similar but more useful for working with arrays. I'll create a for loop in the loop function for, open parenthesis, and we'll say int LED equals 0. So we're creating a new int variable named LED, and we're setting it to 0. A semicolon, LED is less than 10. Keep doing this for loop for as long as our new LED variable is less than 10. A semicolon, LED plus plus, which means that we're increasing our LED variable by 1 each time the loop goes through. So we just created a variable, and the first time we go through the code inside the curly brackets, LED will be 0. Then because of this last bit, we'll set it to 1 for the next go through, then 2 and 3 and so on up to 9. 9. And then after 9, it'll be set to 10. But we won't do the code that time because 10 isn't less than 10. So the loop will only end up running 10 times. At 0, at 1, at 2, through 9. It won't run when it's set to 10 because that's actually the 11th time. And these are the indices of our array. The first item being at index 0 and the last one being at index 9. So inside of the for loop, we can say digital write LED ports LED, comma, high. And now we're going through each LED based on the LED ports list and turning it on. So the first loop, we're saying go to the LED port at the 0th index, which in this case is 4. And then the second loop, go to the LED port at the second index, which in this case is 5, and turn it on also, all the way up to the last LED port, which is 13. Let's upload the code to our Arduino and add in the LEDs. I'll connect the long legs of 10 LEDs from port 4 to port 13, and connect the short legs to the ground line on this breadboard. Then I'll connect a 100 ohm resistor from the ground line to the ground port on the Arduino, and all of the LEDs will light up because we told them to in the for loop. Let's make it a little more interesting though. First, let's add a delay 100 inside of the loop. In between turning on each LED, we have a short break of 1/10 of a second. I'd like the LEDs to turn on one by one, starting at 4 and going up to 13, and then turn off one by one, starting at 13 and going back down to 4. And since this is the loop function, it'll keep doing that over and over. First, let's copy this for loop down, and then we need to change it so it starts at the last LED and decreases to the first and turns each LED off. I'd recommend you pause the video now and see if you can figure out how to do that, because if you can, you're good to go. 3, 2, 1. Okay, so we need to change this int LED so it starts at 9 instead of 0. And we need to continue as long as LED is greater than or equal to 0. Because we do want to run it when it's equal to 0 so that the 0th LED, or the LED at port 4, is turned off. Then we need to change this plus plus to minus minus so we can decrease the LED each time. Now we're going in the opposite direction from 9 all the way down to 0. The last thing we need to do is set the LED to low, so we're turning off the LEDs. As you can see, the LEDs are now lighting up all the way up to all 10 and then turning off down to 0 and so on back and forth, and it just keeps going because it's in the loop function. If you were able to do that, excellent. But if you don't have it all down, feel free to start from the beginning, well, maybe skip the downloading part, and watch it over to really internalize the information. You can even do it on 1.5 times speed if I talk too slow. Once you've done that, check out this video to start on your first Arduino project, a lightsaber. Thanks for watching.